All right, so this video is going to be the first of 4 looking at different polynomial applications. Now on this next slide, there's going to be a lot of information that you want to write down, so make sure that you get all of it. So I highly recommend pausing the video before I start talking about all of it, so that way you can get it all in your notes, and then as I'm describing what you just wrote down in your notes, you can really understand what you did or what you're looking at there. So pause this video and get all of this information in your notes. If you don't want to do that first sentence, you don't have to, but at least from that equation on down with those 4 descriptors there, you want to make sure you get all of that. All right, so let's talk about what this equation is all about. So this equation is going to give us the height of an object after we've thrown, kicked, launched, or whatever the case is that we've thrown it up in the air. And if you think about any object that's thrown up in the air, the trajectory is going to follow the shape of a parabola. And so that's what we're going to be looking at here. So all these parabolas, if you look at that diagram down below, are going to be parabolas that are going to be opening downwards because, again, we're throwing these objects up into the air and then they're coming back down again. All right, so this equation is -1/2 times g. Let's stop there for a second. Now, g is always going to be a number. We just got to figure out what number to use for g. And that's what we have here. So there's 2 values that we could use for g. We could use 32 if our units are in feet. So as you read the story problem, if all of our units are in feet, we would use 32 as our value for g. Or if all of our units are in meters, we would use 9.8 as our value for g. So when you start out with, or when you start this equation, g is going to be replaced by either 32 or 9.8. And you could take half of it, so you can simplify it. So half of 32 would be 16, half of 9.8 would be 4.9. But that's where we would get those values. All right, then let's talk about the v sub 0. So that's what the next piece is. Now, obviously, this is typed up. So how would you write that? What would it look like when you write this? This is v sub 0. That 0 there is what we call a subscript. It is not v times 0. So don't write that in your notes. That would just look weird. So the fact that it's a subscript of 0 means that it's your start. Anytime we have a subscript that's 0, it represents a starting amount. And so this would be what we call our initial or our starting velocity. And then s sub 0, don't worry about this, that's just a comma. So I've had students ask what that's all about. Is that a 1? No, that's a comma. So again, just like the v, that would be s sub 0. So that 0 would be a subscript where that would represent, and I don't know why this textbook does this using s for the height. Maybe because you don't want to get confused with h for our vertex. I'm assuming that's why. So they're going to use s to represent the height. So s sub 0 would represent the initial height. And so all of that again is described there. All right, we're going to come back to this diagram later when we need to reference it again. So let's go to the next slide and look at an example. All right, so it says Larry uses a slingshot to launch a rocket or a rock straight up from a point 6 feet above level ground with an initial velocity of 170 feet per second. So what do you need to get in your notes? I would just pause this video. Make sure that you get the information. So it's being launched 6 feet above level ground with an initial velocity of 170 feet per second. So I would get those 2 numbers written down. You don't need all the other background information. All right. So in part A, it says find an equation that models the height of the rock t seconds after it is launched. So because we're launching it from a slingshot. So if you're wondering why they said launched and not thrown, it's being launched from a slingshot. So what we're going to do is we're going to set up our equation. So remember from our previous page, anytime you're trying to memorize a formula, I've said this before, the best way to memorize a formula is to write it down every time we use it. So we would say s sub t is how they set that up, equals -1/2 times g. I use a capital T because otherwise my lowercase t's sometimes look like a plus sign. So I'll use a capital T just so that way you don't get confused. But we have -1/2 g times t squared plus v sub 0 times t plus s sub 0. So let's plug in what we know. When we look at this information, everything is in feet. So we're going to use 32 as our value for g. And so we would have -1/2 of 32 would be -16 t squared. Plus our initial velocity, that's the 170, so it would be 170 t, plus our initial height, which was 6 feet. Please don't put units in your problem. That's one thing that's strange that I'll see students do when they go to take a test, is they throw units in there, then it just gets confusing. Do not put units in there. It's just -16 times t squared plus 170t plus 6. So that would be our function that we're going to be using to answer part B. So it says, what is the maximum height of the rock, and when will it reach that height? All right, before we answer this question, let's go back to this graph. So what we're trying to do is we're trying to figure out the maximum height. Now, the x-axis represents your time, and your y-axis represents our height. So in the vertex, remember we have that h and k. So the h value does not represent the height. The h value represents the time for that maximum value. The y value, or the k, represents the height. Okay, so when they ask for that, remember what we learned about in the previous lesson was all about how to find the, if we have a quadratic formula in standard form, how to find the vertex. Remember we had that formula h equals opposite of b over 2a. And then remember to find k. K was found by putting h inside the function. So in order for us to be able to find the maximum height, we first need to find our value for h, which represents how long it would take to reach that maximum height. So again, we're going to start by finding when, because that's your time, which is h. Okay, so to find h, we're going to do the opposite of b. So b is 170, so we'd have negative 170 divided by 2a, so negative 32. So when you do that, you get an answer of 5.3125. And that would be seconds. So it would take 5.3125 seconds to reach its maximum height. So again, that's the time it would take to reach that height. So to figure out the actual maximum height, I'm going to use this space down here. We're actually going to answer that next question on the next slide. So to find the maximum height, we're going to plug that number into the equation, because remember that's your k value. So now this is going to be a huge equation, because we're going to have negative 16 times 5.3125. Now I've had students ask me, is it okay if I just round this to make it smaller? We don't want to do that, especially if it terminates after 4 decimals. It means it comes to an end after 4 decimals. We don't want to round it because we want to make sure that our answers are as accurate as possible. Because if I round this to 5.3, we're going to be off by maybe a lot of feet. Okay, so don't round it. If this decimal had kept going, you'd want to use 3 or 4 numbers past the decimal just to make sure, like I said, that we were being more accurate. All right, so we'd have negative 16 times 5.3125 squared plus 170 times 5.3125 plus 6. Again, I'm using this equation to plug those numbers in. Now when you type this on your calculator, please do yourself a favor. Don't break this down into separate parts. Just plug that all in on your scientific calculator. When you do that, you get 457.5625 feet. So that would be the maximum height. It would be 457.5625 feet. Or we could say a little bit over 457 feet there. All right, so let's look at this last part, this last question. It says, when will the rock hit the ground? So to answer that question, let's go back to this visual here and look at our parabola. And when it hits the ground, think about what that represents. That represents the X Intercept. Now technically, yes, we do have 2 X Intercepts here, but this one we don't care about. The reason why is because that value is going to be negative, and so we don't care about the negative value, because all of this starts when it's being thrown, which would be that initial height there. So we don't worry about that point that's going to be to the left of the y-axis, because that's going to be negative. Now, how do we find that point? Well, remember, to find this point, this is where we would use that quadratic formula. So the quadratic formula is used to find the x-intercept. So we'd have negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac, and all of that's divided by 2a. So that's how we're going to find our x-intercepts. So to set up, you have the equation in your notes, so you can look at that. So it'd be x equals the opposite of b, so it'd be negative 170 plus or minus the square root. Now for this one, I'm not going to type in 170 squared in my calculator yet. I'll do that in just a minute, so we'll just leave this at 170 as 170 squared. Minus 4 times a is negative 16, times c, which is 6. And all of that's divided by 2 times a. So a is negative 16, so that would be, oops, negative 32. All right, let's find the discriminant. So that's the piece underneath the square root. Let's find that first. So when you do that in your calculator, when you take 170 squared minus 4 times negative 16 times 6. Again, do that all in one piece on your calculator. Don't break that up into separate parts. That's where you're more likely to make a mistake. But you should get 29,284. Now, if you do the square root of 29,284, that does not work out nicely, but we're just going to write this as a decimal. We'll just say 171.13. All that's divided by negative 32. Now, remember, we said that there's going to be two solutions, and we only care about one of them. So we got to figure out which one it is, because to be honest, I don't want to sit here and type all this in and then find out I just found the negative one, and so all that work was done for nothing. So let's think about this logically. Let's say I did the plus. So if I did negative 170 plus 171.13, think about that for a second. Would my answer be positive or negative? So if I did negative 170 plus 171.13, hopefully you're thinking your answer when you add those together would be positive because the positive one is bigger. And if I take a positive number divided by a negative number, my answer would be negative. So we don't want to waste our time doing that one because our answer would be negative. So let's try the negative or the minus part. So if I did negative 170 minus 171.13, that's going to be a larger negative number, and that larger negative number divided by another negative would be a positive answer. So that's the one that I'm going to use. And to be honest, every time you do these for this particular type of problem, we'll be using the negative one. And so when you do that, you end up getting, and again, do this as two parts. So when you go to do this on your calculator, do the numerator first and hit enter. And after you do that, then you hit divide by negative 32. And when you do that, you get your final answer of 10.66 seconds. So it takes about 10 points, little over, so almost 11 seconds. So 10.66 seconds for the rock to hit the ground. All right, so that is our first application problem dealing with the height of an object. And so why don't you guys, if you want to stop here, you can work on questions 1 and 2 in your homework packet for this section.